Okay, so now that we have seen how to train our model and do the prediction part, next we are going to see how to evaluate and analyze the model. Okay, so in scikit-learn we have tools for that. In this library scikit-learn.metrics, we have these three functions, which are accuracy score, confusion matrix, and classification report. Okay, so those are the three things we are going to see. There are a lot of other things, but these things we'll be using more often, right? So let's see how those things are. So using them is very easy. You just import them from scikit-learn.metrics and then just directly call them. The first argument is always the true value, which is in our case y test CLF, and the second argument is always the predicted values, which is y pred. The accuracy is between 0 and 1. So if you want a percentage number, then we have to multiply it by 100. And we will see what the confusion matrix and reports look like. Okay. So when you execute it, we had accuracy is 89%, which is 89% of the time we were able to predict the correct class, but 11% we were not able to predict the correct class. We made a mistake. If you want to see where exactly we made the mistake, the confusion matrix gives you more information. So there are 68 data points where the actual class is 0, right? And for that, 67 of them we were able to predict it correctly, but for one of them we didn't predict it correctly. And similarly, there are 32 data points for which the class is 1, the target is 1, and out of them 22 we were able to predict correctly, and 10 of them we predicted 0, right? So we are making more mistakes when the class is 1. So that's our analysis. Further analysis we can do by printing the classification report, right? So here you get all the details. So how many data points are there for each label? So 0 we have 68, 1 we have 32, right? We get all these numbers like precision, recall, and F1 score. So precision is basically how precise we are. For example, in the class 0, it means that we predicted 0, 67, and 10, right? So how many of those time the actual value was also 0, right? So 67 divided by 67 plus 10 was the actual precision, which is 0.87, right? The recall is this number 67 divided by 67 plus 1, which is out of the all 0 examples, how many times we were able to predict it correctly, right? So that is 67 by 68, which is 0.99 over here. F1 score, it basically combines both of these numbers, precision and recall, in some way, right? So that also you get it over here. Okay, so that's pretty much it for the model evaluation analysis. If you want further analysis, you can actually try to visualize it. So let's do some visualization. So these parts are not really part of this course, but I'll just show you how the decision boundary looks like in a logistic regression classifier, right? So we just trained the logistic regression classifier, and when I plot it, it looks something like this. So these are examples for males, and on the x-axis we have age, and y-axis we have estimated salary, and the green dots are the ones who purchased it, and the red dots are the ones who did not purchase that, right? So our model learned this decision boundary, and you can see that on the one examples we are making quite a bit of mistakes, right? And similarly, this is the graph for females, and this is on the training data set. This is not even the testing data set. Okay, so again over here also in training we are making mistakes with a lot of green, and a bunch of reds are also here on the other side. If you look at the testing part, we can again like call the same function over here. So this is not really part of scikit-learn. So this is like a custom function that I wrote, which is not there in scikit-learn. Okay, so on the testing data set, we can see something similar, right? So pretty much all the red dots are on this side, and all the green dots are on the other side. So one thing that you need to remember about logistic regression, that it's a linear model, right? So that this decision boundary that is separating the two classes is a line, is a straight line. It's not really any kind of a curved surface. So that's some sort of a limitation of this model, but we'll see other models that go beyond this, right? So that's pretty much all about evaluation and analysis.